everyone, my name is Aishwarya. In the course of Design and Analysis of Algorithms, let's discuss some more examples to analyze the iterative algorithms time complexity. So let's see if you have any instruction like this. While n is greater than 2, the instruction is, let's say, n is equals to under root of n. If you are doing square root of your number, what will be the time complexity? Let's see, you can rewrite this instruction as n is equals to n to the power 1 upon 2. It's fine? Yeah, it's fine. So once you are executing this code, what will happen is under root n will become under root. So you can write it like this, n upon 1 to the power 2. This is 1 to the power 1, right? Now again, you will execute it for n greater than 2. It will be n to the power 1 upon 2 to the power 3. N to the power 1 upon 2 to the power 4. How many times it will execute, students? It will execute n to the power 1 upon 2 to the power k times is equals to what? 2. These number of times it will execute. So we just have to analyze, we just have to find the kth value from this equation. How we can do that? N is n to the power 1 upon 2 to the power k is equals to 2. As I told you that whenever you see any exponential terms, you just have to take log. What you have to do is you have to take log base 2. What it will be? It will be log of n to the power 1 upon 2 to the power k is equals to log of 2 base 2, right? So you can just take this out. You can just take this out. I will show you with another color. This is going to come here. And this value you all know will be equals to 1. So it is 1 upon 2 to the power k log of n base 2 is equals to 1. Now, you can just take this 2 to the power k into the right side. It will be like this. Log of n base 2 is equals to 2 to the power k. Again, you are having an exponential term. You can just take log again. Take log again. Okay, I'm writing over here. It will be log of log n base 2. This is also base 2 and it will be 2 to the power k. Sorry, it is log 2 to the power k, right? So this is a log of log n base 2 is equals to k will come in multiplication and it will be log 2 base 2, which is equals to 1. So k value, the number of times this instruction will execute is log of log n base 2. This is the number of times. So whenever you are seeing any instruction which is having n is equals to under root n, you can directly see the time complexity for the instruction will be n will be log of log n base 2, right? Now see for next example, if you have to find the time complexity for the iterative function to sum a list of numbers. You have list of numbers as in float list and you just have to sum all the numbers. What you can do is, first of all, you have to write what is the number of what is the instruction is, what is the frequency, and what are the total number of steps. So if you see when the function calling, this statement is just a function calling. So the frequency will be 0, total steps will be 0. This is opening bracket, also 0. Now this see this is a float variable declaration as well as the assignment one. It is you are assigning the 0 value to temp sum. Then it will take constant time, which is 1. This is simply a declaration, so it will be 0. Now loop, check for the loop now. I have told you that whenever you have some basic operations, it will take constant times. But if you have loop, you have to check how many times that loop is executing. So you can see this loop is executing from 0 to n. It will execute n times for the true condition, but 1 time more for the false condition. N times it will execute for the condition will be true and 1 time it will execute for the condition will be false. So that's why it is written as n plus 1 will be the frequency and 1 into n plus 1 will be your total number of steps. Similarly, for true condition you will enter into the loop. So this particular instruction, this particular statement will execute how many times? It will execute n times. So it is 1 into n is n. This is totally a basic operation. You are returning the value of temp sum, which will take 1. So you can just add the total steps. 1 and 1 is here also, which is not visible here. So 1 plus 1 plus 1 is 3 and n plus n will be 2n. You can rewrite this as order of magnitude n. These constants can be ignored. So this is how you can check for the frequency and total number of steps, which will give you the time complexity of any iterative function. Which iterative function? Okay, let's see for another one. See for another. Okay, I will just focus on these instructions. I will not focus on the main function and everything. I will just focus on the loop part, because this loop part is going to give you the time complexity, right? This loop part will going to give you the time complexity. So check. Can you see how many times this I loop is executing? It is executing 1 to n, means it will execute n times. N plus 1, 1 for failure, n plus 1 obviously, and it can be rewrite as n because 1 is for false condition. Now for n values you will enter into the loop, and for that how many times j will execute? See, j will execute for 1, j will execute uh, when j will execute for 1, j value will update. It will execute from 1 to n. See, it will execute from 1 to n, but every time value is being doubled. So for 1 it will print hello, then for 2 it will print hello, for 4 it will print hello, 4 to the 8 it will print hello, 16 it will print. So for every doubled value it will print hello, for not for the every value. So if you have total n values, how many times it is printing hello? It is printing hello for n by 2 times. What is the time complexity if the instruction is having n is equals to n by 2? I told you, log of n base 2. Every time you are dividing the value by 2 by 2 by 2 by 2, so the time complexity will be log n base 2. So what is going to happen is this instruction will execute how many times? Log n base 2. As you can see in this particular program, this is a nested loop. What kind of loop it is? Nested loop. Whenever you see any nested loop, you just have to multiply the time complexities. So for the loop number 1, which is n, into the time complexity for loop number 2, which is log n base 2, total time will be order of magnitude n log n base 2. This is how you can find the time complexity for any iterative program. See for one another, then I will show you how these will execute also. Let's see. This loop is executing from I is equals to 1 to n. Now you can see for that j is executing from 1 to I times now. It is executing upon on previous one. This loop is dependent on the execution of the previous loop. These kind of loops we have to unroll. These kind of loops we have to unroll them. How we can unroll them? Let's see. Third loop is also executing from 1 to n. It is not dependent on anyone. Only this loop execution is dependent on the previous one. So how to unroll? Let's see. For I is equals to 1, we have to check for every value of I. For I is equals to 1, j will execute from how many values? 1 to 1 to less than equals to I, which is 1. So 1 to 1. For that for j is equals to 1, k will execute from 1, 2, 3, 4 up to n. So k will execute n times, right? This is 1 to 1 is 1 time. Let's say I is equals to 2. You will understand once I'll write more I is equals to values. So for I is equals to 2, j will execute how many times, students? It will execute from 1 to, how many times? I less than equals to 2 means 1 to 2. And for that, for j is equals to 1, k will execute 1, 2, 3, 4, 5 n times. For j is equals to 2, k will execute 1, 2, 3, 4 n times. For 1, it will execute k times. For 2, it will execute k times, right? Let's see for I is equals to 3. Now I think you will get to know. For that, j will execute from 1 to how many times? 3 times, right? I value is 3. So it will execute from 1, 2, 3. For that, for j is equals to 1, let's see. For that, j is equals to 1. What will happen? Okay, for that j is equals to 1, k will execute how many times, students? It will execute n times. Then for j is equals to 2, k will execute how many times? N times. For j is equals to 3, k will execute how many times? N times, right? Now let's move in forward. For I is equals to n, for the last value of I, j will execute how many times, students? It will execute from 1 to less than equals to n, right? And for that, k will execute how many times? For 1, it will execute n. For 2, it will execute n. For 3, it will execute n. For n, it will execute n. Now you just have to add all these time complexities. You just have to add these number of times, which will give you total time. Let's see how we can add. Let's see how we can add. Okay. Let's see. I'm trying to write it. Let's say I'm writing here. Okay. Total time for this algorithm will be, let's see. Okay, I'm writing here. You can understand here. Okay. Okay, see, I is equals to 1. I is equals to means 1 means for value of I is equals to 1. It's not number of times. It is just value of I. Means number of times it will be 1 only. Because I is equals to means I is equals to 1 is 1 time. Into, I told you, when you have nested loops, you have to multiply the type complexity. So I then J. J is executing how many times? 1 to 1 is 1 time. 1 to 1 is 1 time. And for that, K is executing how many times? K is executing n times. This is the total time taken by the loop when I is equals to 1, J is equals to 1, K is equals to 1 to n. Right? Now for this. See, I is equals to 2. I is equals to 2 means I is the value is equals to 2. I's value is equals to 2. But number of times how many it is? It is 1 only. Now for that I is equals to 2, which is 1 time. J is executing how many times, students? J is executing, for I is equals to 2, that is number of times is 1, and for that J is executing how many times? 1 and 2 means 2 times. It is executing 2 times. And for that K is executing how many times? N, and n means 2n. This is n, right? This is how you can make the equation. I will do it in the fresh phase. Let's see. I'm writing it. I is equals to 1. For that J is executing 1 to 1, and for that K is executing n times, right? Let's say for I is equals to 2, J is executing from 1 to 2 times, and for that K is executing n times, n times. Now I is equals to 3, J is executing from 1 to 3 times, and for that K is executing n times, n times, n times. Let's do it for I is equals to n. J is executing from 1 to n times, and for that K is executing n time, n time, n time, and so on. Right now. Now just to sum all the values, which is T of n. Time complexity for like a program is, when I is equals to 1, it is number of time is 1. Here I am going to write only the number of times, not the value. For that J is also executing 1 time, and for that K is executing 1 time. This is 1 plus. Plus what will be the I is equals to 2? I is equals to 2 is only 1 time. For that J is executing for 1 and 2 means how many times? 2 times. And for that K is executing 2 times, which is into n. Plus I is equals to 3 only 1 times. For that J is executing 1, 2, 3 means kitne times? 3 times into n. Plus last what we can write it as n. You can write it as 1 into n into n. Right? Now, just take n out of all these terms, which is 1 plus 2 plus 3 plus 4 plus till n. It is plus n. As you can see, n, this is the sum of natural numbers. Sum of n natural numbers. What is this? Sum of n natural numbers. And what is the formula for this is n into n plus, what is the sum of n natural number is n into n plus 1 by 2. You can see it as n square plus n by 2, and it can be said as n cube plus n square by 2. The worst case from both of these will be order of magnitude. You can write n cube. So time complexity for this iterative analysis will be, iterative program will be order of magnitude n cube. So this is how you can analyze the iterative programs and find the time complexity for it. Thank you so much.